Hello and welcome to the MoonCast web video blog series. I'm your host, Ron Marugandi, and in this series we'll be introducing you to the exploits of the recently launched NGL, or Next Giant Leap X-Prize lander, and the Lancer communication satellite. The NGL lander and Lancer spacecraft just recently launched from Cape Canaveral, Florida aboard a Falcon 9 launch vehicle, with the goal of winning the Google Lunar X-Prize. The Google Lunar X-Prize is a competition that awards $20 million to the first privately funded team to land a spacecraft on the moon, move it 500 meters, and send back high-definition video. We go live now to the moon as the NGL lander is about to make its final descent. The NGL lander spacecraft's descent began from a 100-kilometer parking orbit, where its first descent stage fired for 8 minutes. After jettisoning the first descent stage, the NGL lander continued braking with its own thrusters. At an altitude of 1 kilometer, the NGL lander began looking for a landing spot clear of craters and large debris. It looks like the NGL lander has found a good site and is about to land. Wow, that was exciting. Congratulations to the NGL team. As a part of the Google Lunar X-Prize mission, the NGL lander will achieve many historic firsts. Let's go live back to the moon to witness some of these historic events. The first text message sent from the moon. The first email sent from the moon. The first MP3 sent from the moon.
Never gonna give you up, never gonna let you down, never gonna run around and desert you, never gonna make you cry.
In addition to all these firsts, the NGL lander will also be sending back hours of HD video and hundreds of pictures from the surface of the moon. Now it's time for a series we like to call Moontastic Tech, a weekly series where we will learn about the amazing technology aboard the NGL lander and Lancer spacecraft. This week's series is on the LaserCom system, which allows us to get high data rate back from the moon to the Lancer spacecraft.
The LaserCom terminal aboard the NGL lander allows it to communicate in a very high data rate with the LNCR communication satellite. The LaserCom terminal is capable of transmitting data at a much higher data rate than the radio frequency dish also on the spacecraft. The LaserCom terminal on the lander consists of a 35mm telescope and the precision gimbals and actuators required to point it. Laser communication is similar to radio frequency or RF communication in that they both use electromagnetic waves to transmit data. All electromagnetic waves travel at the speed of light, so how does one method transmit more data than the other? Well, to begin with, RF and LaserCom use different methods to send data. RF communication begins with data, a bit stream of 1 and zeros, and modulates it into a carrier frequency. It is on this frequency that the signal is carried from the transmitter to the receiver. Data can be modulated onto the carrier frequency using amplitude modulation or frequency modulation. LaserCom, though, uses a technique very similar to fiber optics here on Earth. The transmitting terminal, once having acquired the receiving terminal, sends the bit stream in a series of pulses. The receiver getting this signal interprets either a signal present, no signal present, or either a 1 or a 0. To those unfamiliar with binary digital communication, this method is similar to Morse code. So now the question is, how is one method able to send data at a higher rate than the other? The answer is wavelength. But to get to this answer, we have to go through some electricity and magnetism theory, so bear with me as I give you a quick rundown on it. A primitive source of radio waves will radiate electromagnetic waves in all directions away from it. The power received from this transmission decreases as you get further away. If the signal is not strong enough where you are receiving it, you won't be able to understand the transmission. To increase the intensity of a signal at a particular spot, higher gain antennas are used to focus the transmission in one particular direction. The gain of antenna describes how well it can send a signal. Higher gain means it is more effective. Gain depends on a number of factors including the antenna efficiency, physical size of the antenna, and the wavelength of the wave being transmitted. The wavelength is the key factor we're interested in. Notice the wavelength terms on the bottom of the gain equation, so a smaller wavelength means a higher gain. Radio frequency waves used in satellite communication in the S-band have wavelengths of around 1/10 of a meter. Laser light, however, has a wavelength around 1,000 nanometers, or 100,000 times smaller than radio frequency wavelength. Waves with a smaller wavelength diverge less than larger wavelength, meaning that their intensity can be more easily focused and travel longer distances. Since laser light has such a small wavelength, the gain from the laser terminal is much larger than that of RF antenna. What this means for a spacecraft is that if it has a high gain system, it doesn't have to put as much power into the system or have as large of an antenna. It also means that a relatively small lasercom telescope is able to send data at a very high rate. That's all the time we have for this week on Moontastic Tech. Tune in next week to learn about the pointing requirements for laser communication.
Wow, that was cool. Now is the time in our program where the NGL Lander is going to do something requested by viewers at home like you. Our web poll has been open for a month, asking what you would like to see the NGL Lander do on our first episode. The options to choose from were to have the NGL Lander wave, take a picture of the lunar landscape, take a picture of the Earth from the moon, or take a picture of a rock and name it after Stephen Colbert. And you, the viewers at home, chose to have the NGL Lander wave to everyone back here on Earth. Well, that's all we got for this episode, folks. Thanks for tuning in to the MoonCast web video blog series. Make sure to join us again next week to see what crazy thing we have the NGL Lander do next. Stay classy, world.